Uh, Thanks for listening to the talk. I'm Isabel, and I'm going to talk about what we can learn about language from exploring multilingual language models. So, some context that we all know, but just to see where I think we are, it's that at last we have language models that model language pretty well. Not perfectly, but to a first approximation, it works when it didn't used to. And this gives us two things in my views. It gives us a scientific mystery that's very cool. And there's whole tracks dedicated to interpretability and analysis at our conferences now. And it also gives us a scientific tool. Now this second one is maybe a bit less intuitive. So I'll go into it a bit. How are language models and tool? Well, we have this amazing thing, which is that we have language learners that learn in front of our eyes, and we can manipulate them. For example, by looking into their representations, we can get ideas about how complex linguistic properties are related, or can be jointly encoded, or can't be jointly encoded in this model. By observing this learning under controlled conditions, this learning which now works and didn't used to, we can investigate things like the inductive learning biases that contribute to language learning being possible. And so what this talk is, it's going to look at this question of analyzing language models and trying to gain something for language for it through a multilingual lens. And then I'd also like to go a bit beyond human language to other typologies like code and music and structural primitives like recursive languages and non-recursive languages to understand to understand kind of how these modalities relate to human language, and if that can help us understand these questions as well. So essentially, a basis of how I'm trying to look at and understand language models is through thinking about language variation and universals. There's kind of two ways to think of language universals, right? They can be concrete, so it's questions like how to understand multifaceted cross-lingual properties, and to get at these kind of linguistic properties, LM embedding spaces create a plausible testing ground to poke around in and understand. And then on the other hand, there's abstract universals, like the types of things that underlie language, if there are kind of abstractions that underlie all languages or not, and we could use language models under controlled conditions to ask, what are the inductive learning biases that make good language learners, and to start getting at what could be the abstractions that underlie language. These two views of universals, I don't think that one is better than the other. This wasn't like a progression slide, from the simple to the complex. I really think there's a lot to gain from looking at both. And so now, getting back to this general question of learning about language from language models, can we really prove anything? This is just some kind of artifact, that's created by some big company. And the answer is no. We really can't prove anything. But a language model is a concrete theory for how to model a language. This train of thought is very much influenced by Marco Baroni's paper, though all mistaken takes are the author's, my own fault. But yeah, it's a concrete theory for how to model a language. That's obviously not perfect, but neither are most theories, right? If you take your favorite kind of grammar, it's not really going to model English well. It's going to model English. It's not going to model English perfectly. But what's cool about having a language model in our hands is that we can investigate it. Unlike unlike just a speaker of a language, we can investigate it in all these cool ways. And then also it's thinking outside of the box in a way. It's not a theory that's kind of been developed from academic communities. It's going to kind of come at us from left field with how it's learned language, and sometimes these might just be mistaken assumptions, but sometimes it can help us. And so, in some sense, what computational models provide in language, but I think also in cognition in general. It's never proof, but they provide possibilities and interesting cases that we'd not considered before. So this talk is I'm going to go over two parts of my work. So firstly, I'm going to look at representing subjecthood. So that's the quality of being either the subject or the object. The dog chased the cat in a sentence. It's a very basic linguistic quality. And then I'm going to look at transfer learning with syntactic primitives, looking at questions like recursion or non-recursion. Subjecthood, it's a discrete category. In some sense, you're either the subject or the object, but it also has all these subtleties and complexities. And language models put all of this, and multilingual language models put all of this in many languages into one coherent, continuous space. So how does this all work? Is the question that we're going to ask, and I think that this can teach us a bit about subjecthood. On the other hand, looking at transfer learning with syntactic primitives, we can pre-train on non-linguistic data, and that creates learners with inductive biases that we know because we've just pre-trained them in, which is amazing, right? It's not something that we've been able to do before to the scale, to just create a learner with a known, create kind of like a big learner, but where we know the inductive bias. And this gives us a window into understanding what could be and what could not be a useful inductive bias for language learning. So, on to the first part of the talk. The property that we're looking at is subjecthood, right? It's the property of who does what to who, being the subject of a sentence versus being the object. So I have the dog chasing the cat. And subjecthood is something which is relevant in basically every utterance in every language, right? It's kind of like a theory independent way of most utterances contain this. So it's very cool to look at. And also, on the other hand, it's very not simple how it's handled, and it's handled very differently in different languages. So it kind of offers us this like depth of typological variation. And what's cool about subjecthood is that it's complicated, as I said, right? On the one hand, you might say it's actually not complicated, right? I take my tree from my favorite grammar and I traverse it, and I can totally deterministically tell you what's a subject and what's not, right? But then there's all these complexities, right? Like in intransitive, we treat the subject as the subject, but it's often just like it's not the agent of the action pretty often, right? Or in terms of animus, a subject being animate kind of makes it more of a doer, right? Or in terms of passive voice, with the passive voice in English, we can promote, not just the object, but things like the destination to be the subject of an action. Things like volitionality, whether an agent means to do something or it's just kind of something that happens to their brain, like with a verb like forgot, kind of influences the subjecthood, right? And things like case, not in English as much, but in other languages where it's relevant. Expletive subjects, right, like there and it, and so on. It's really not a simple case. And multilingual language models, which what they do is that they represent words in different contexts, in different languages, all in one high dimensional space. So what we want to ask is, how do they do this for subjecthood, which is this property with all these subtleties that we just went over? How can that work? So subjecthood in multilingual language models, it's kind of two sides that we get. On the one hand, subjecthood is this concrete handle for looking into language models' internals and trying to understand what's going on. And language models internals in the form of this one big syntactic space give us a concrete view of how multilingual subjecthood can be represented and influenced. So firstly, I'm going to go over a paper, Deep Subjecthood, with Ethan Chi and Richard Vitrell and Cal Mahawal. This was at EACL last year, and basically we try to answer three questions in this paper. Or at least get multilingual language models kind of take on three questions. Is subjecthood a universal category? Is subjecthood a discrete category? And what happens with all this typological variation that exists with subjecthood? And the main experimental tool that we have is that we train a binary classifier on multilingual BERT embeddings to distinguish subjects from objects in one language, right? And what we're interested in is how, not if, the classifier encodes subjecthood. And so we have this classifier that defines a probability space between object and subject. And what we're interested in is how it acts, not exactly that it can represent it. Subjecthood is a pretty basic quantity. You can probably extract it from many language models, right? There's much more difficult probes that work. And so what we're really interested in is the how. And so to answer our first question, is subjecthood universal in multilingual BERT? We can zero-shot transfer classifiers from one language to another, right? So we have a classifier that works in English, and so in a sentence like the cat is chasing the dog, if we give it cat, it outputs subject. If we give it dog, it outputs object. And then we ask, okay, this is multilingual BERT. If subject is encoded kind of jointly for all languages, this classifier should work for examples in other languages. If we give the subjects or the objects of examples in other languages, will this work? And what we see actually is that it works pretty well, right? So the cross-lingual accuracy of our classifiers is comparable to the in-language accuracy. And in this graph, we have for every source language, we have how well the classifier performed in the subject-object, in the binary subject-object classification task over all the other languages. And the red dots are the in-language accuracy, and we see that they don't really stand out, right? So though obviously the in-language accuracy is amongst the best, it's not that there's a huge performance drop with going to any other language. Of course, there's a performance drop with going to like the worst other language. So it's not a totally jointly represented thing. And then just expanding out this graph, so we have like source language and destination language on the X and Y axis. We see again that the diagonal doesn't really pop out, right, like it does in some graphs. So the in-language accuracy is not really popping out. And interestingly, also I want to point out that English, even though it's kind of dominant in multilingual BERT in terms of taking up space in the vocabulary and all that, is really not coming out as a standout, source if we look at the vertical lines, or as a standout destination if we look at the horizontal lines. In fact, the real standout destination are case Slavic languages, right, like Polish and Russian and Serbian and Croatian. And so what we've seen is that BERT has a multilingual BERT encodes this parallel multilingual subjecthood. And so we see that in pre-trained language models, or at least in the one we look at, there is linguistic generalization, right? They encode subjecthood separately from language. And why this is interesting, it's because this property, that we do believe is universal, it's available to a statistical learner as universal, and it seems that the best way in multilingual BERT training regimen to deal with all that data was to encode this property as universal. So this is very interesting data to have around when we're thinking about subjecthood in linguistics, right? But I was talking about binary classifiers and their accuracies this whole time. But subjecthood, as we went over, it's not really a simple binary issue, right? There's of course camps that do believe that grammatical kind of discrete binary subjecthood is very important, and then there are many linguists who believe that the prototype effects that make subjecthood are very much like the basis of how we should think of transitivity and subjecthood, and kind of grammatical structure does not feature as prominently in their analyses. And multilingual language models, I argue, and I hope I'll show here with these next experiments, can really help us tease out this conflict and understand, what is a middle ground that we can take. And so again, we have our binary classifier that that distinguishes subjects from objects, and again, we're going to look at the probabilities more carefully this time, because we want to see how, not if the classifier encodes subjecthood, we want to see the effect of different prototype effects. So, and what we find is that classifier probabilities do show prototype effects. So first we're going to look at animacy, right? So this is the quality of being kind of an animate being that has choices and makes decisions versus not. And we're going to ask, okay, what is the effect of animacy on our subjecthood classifier? And what we see is that when we separate our test set by animacy, and we only do this for the languages where we could get animacy annotation, so it's not all the languages that were in the previous graphs are here. But when we do separate our classifiers by our test set by animacy annotations, so that's on the x-axis we have animate and inanimate, and we also separate it by syntactic role, right? A for subject, O for object, S for intransitive subject. We see that animacy has an effect, right? So within each ground truth role, even though in general subjects are being classified as subjects, right, above 50%, and objects are being classified as objects above around 50%, having kind of the non-prototypical animacy, so being an inanimate subject, brings an example much closer to 50%, and being an animate object also brings examples much closer to 50%. And so we see that these prototype effects are really being expressed in the embedding space, even for as the classifier sees it. And then also we look at passive voice, right? So what if we take out all the examples in our test sets, which are in passive voice, and look at those differently? And what we have in this graph, we have the probability distribution of kind of all classifier probabilities for these three for the different grammatical roles, and this is kind of the cross-lingual probabilities. So it's every classifier, for every item in the test set in every other language, and we see that subjects, it's this yellow line, are very much treated like subjects. Objects generally get lower probability. Intransitive subjects a bit less. And what's interesting is that the passive voice, this blue line, just kind of splattered out across the whole probability space, right? So the fact that passive voice is kind of difficult is kind of difficult to really treat something like a subject. If it's a passive subject, that's reflected in our classifier. And so we see prototype effects in mBERT embeddings, and it illustrates how many factors play into making something a subject. In these experiments, we also look at case, and then I'm very interested at looking at the effect of discourse features and information structure in spaces like this, and how it works. I think it's a huge part of subjecthood. But what these experiments, they then beg the question, is it all just prototypes? Maybe in a space like multilingual BERT, there really is no, this kind of discrete, clear grammatical subjecthood really isn't playing a role. And this is the question that we contended with in our paper at ACL this year, again with Richard and Kyle. And what we asked is that, okay, if the classifier is not paying attention to grammatical subjecthood, what if we test the same classifier probe on sentences, on pairs of sentences which are the same, and so they have all the same prototype effects, right? All the animacy effects, all the kind of distribution, all the words around them effect. But what if we swap the labels, right? And so in the one case they'll have to predict one thing, and in one case they'll have to predict the other, right? And in English, there's a very easy way of swapping the labels of a subject and object. You just swap their position. In many languages, this is not simple at all. But since in English it is, we focused these examples in English. And so what we ask is, will the probe be able to tell chef as a subject and chef as kind of like out of distribution object apart, right? Because grammatically in the second sentence, chef is an object, but if you're kind of working with prototypes and reliant on distribution, it's you're gonna get fooled, right? Because this sentence doesn't really make sense. And what we find is that yes, right, representation, there are these representation differences in the probe that are caused only by syntactic word order. To explain this graph a bit, we have the probe probability of subject here at on the y-axis, and on the x-axis we have the BERT layer, and we compare the probabilities on our whole test set of original subjects. So it's not just for this example sentence, right? This is an average over our whole test set, and then for those same subjects when they're then made into objects, so the ground truth probability would be 0, and we see this separation, and which is pretty cool. The sentences that we use are kind of big and complex, are just taken from UD, so they're not like templates, like the X verbed the Y or something. And so it's cool that we see this separation, which shows that there is this discrete notion of subjecthood. The fact that grammatical subject is important, it is in there, and I think that this really opens up a lot of doors. This kind of fact that we've shown that both grammatical subjecthood and prototype effects figure in multilingual BERT embedding space, and I think it's very interesting to understand how a representation can embody both of these types of information, and really language models are a tool to better understand this middle ground, which I think is very precious. It's something that has been talked about a lot. Which of these is true, and I think that to really understand compositional middle ground is very precious, and I think that LMs provide this rare tool for that. Lastly, we're going to look at typological variation in subjecthood, right? And we're going to focus on intransitives. So we know that subjecthood is encoded in parallel between languages, but are the particularities of each language also encoded? And also encoded, sorry, that skipped ahead. Yeah, and just a small recap of terminology, right? An intransitive verb, or an intransitive sentence only has one argument of the verb, right? There's not both a subject and an object. There's just one argument. We in English, treat it and call it a subject, but as I mentioned before, there are many cases when the intransitive subject is kind of the object of the whole action, right? Is not the agent, and so it makes sense that that many languages actually treat intransitive subjects and call them objects. Second. Yeah, and these are called ergative languages. And so in an ergative language, just how we in English conceive of the only noun around intransitive verb as the subject, in intransitive languages it is the object. And so what we ask in this part of the experiment is, do we see this variation in intransitive treatment, this alignment of either, like English or ergative in multilingual BERT embedding space? And what this is really asking is, can higher order features, right, this information, which is kind of about the whole language, it's not really in any one utterance, can this be represented in embedding space? And so how we find this out is that we hold out intransitives from classifier training, right? So the classifier is now trained from to distinguish transitive objects from transitive subjects, and it's never seen intransitive. So it's going to have to make its own decision about where these lie when we ask this. And so the classifier probabilities are going to tell us whether intransitives align with the transitive objects or whether they align with the transitive subjects. And what we find for most languages, and here I've pulled out Serbian, is that classifiers do reflect the fact that intransitive subjects aren't full-on subjects, right? So in Serbian, which is like English in that it's nominative, we do see that the green line, which represents intransitive subjects, is kind of lower than the orange line, which is the transitive subject. And we see that this is the case in all of the languages. But what's interesting about this graph is that if we order, is that we have ordered actually already the languages by how far away the transitive subject and the intransitive subjects are, right? So how big this difference is perceived to be by the classifier, right? And this ranges from the green line being like just hovering at 50%, being kind of equally a subject and an object, to the green line being like almost as close to the orange line as possible, right? And what we find is that the languages with the biggest gap between transitive subject and intransitive subject are the only languages that we look at which have ergative alignment, right? Basque has ergative alignment in basically all cases, and Hindi and Urdu have a split ergative system where in some tenses there's ergative style alignment. And so what's interesting is that about this is that the classifiers reflect intransitive alignment, even though it's a feature of a grammar, right? It's not a feature of any one utterance, right? It's kind of a feature that one type of utterance is kind of more like another than another. But this is apparent in embedding space somehow, even when they are held out. And I think this is very important, kind of about if we're to understand how kind of syntax and the lexicon can kind of coincide, how separated are they? I think that doing experiments like this, seeing what can be held in one space is very interesting. Yeah, so going over what we learned in the subjecthood part of the talk, subjecthood representation, it can be, and it is, multilingual. Prototype effects, they coexist with discrete grammatical classes, and higher order information like what to do with intransitives is represented in the same space as meaning, which is cool. Now, on to the second part of the talk, which is transfer learning with syntactic primitives. This is largely based around a paper with my advisor Dan called Learning Music Helps You Read. And the main question that we're trying to get at is, what structural inductive biases make a good language learner? And the issue that we're dealing with here, again, this formulation is very influenced by Marco Broni's paper, is that we can't really have blank slate learners that work, right? We can have a blank slate kind of like small connectionist model or something, but it's not really going to model language in any impressive or interesting way. And now that we have large models that can, they come with many inductive biases. And so if we want to make arguments about learnability, we can't use the former, we can't use the latter. We're kind of stuck. Where are we? We're not. What we do in this paper is that we argue that if we're careful about the data that we pre-train with, pre-training can create a powerful learner, right? Because it's a big model that is powerful, but it has a known inductive learning bias because of what we have fed it to pre-train. And so I'm not talking about pre-training like just on like Wikipedia. You have to be careful about what kind of biases you put in if you want to make scientific claims of this type. Yeah, and so just illustrating just the very broad process behind this paper. So you have a powerful untrained model which has unknown inductive biases, and when you pre-train it on this kind of non-linguistic data that we're going to talk about later, what that could be, you end up with a powerful learner whose inductive biases we do know because we pre-trained them in. And this is a position that we thought we couldn't be in, really, right? And so it's cool to get there. And then when we transfer into language, we can ask, what can this model learn from language data? And this is where we can kind of start making learnability arguments. With this inductive bias, it's easy. With this inductive bias, it's hard to learn language. For pre-training data, we look at both real data and synthetic data, right? For real data, we look at music and we look at code. So these are two types of data that like share structural similarities with language, but aren't linguistic and have very different surface forms. And on the other side, we look at synthetic structural primitives, right? So we take like a hierarchical language, like a nesting parentheses kind of Dyke language, and also non-hierarchical languages, right? So which look like they might be nesting parentheses, but actually they're not nesting. Here you see all the arrows crossing. And a small just methodological note on these experiments, that transfer learning should be constrained, just because, if we're trying to talk about inductive biases, we want to make sure that we're using the inductive biases, not pre-training, right, with the language, because then we're just back to having a big old model that we can pre-train on Wikipedia, but we don't know what that means. And there's two ways of constraining transfer learning, right? We can limit the data, or we could limit the trainable parameters. For this set of experiments that I'm going to describe now, kind of like the proof of concept for this idea experiments, we do the latter. So we freeze everything except the word embedding matrices, right, at the beginning and the end, which are tied to be the same matrix. But and so if we freeze everything except for the word embedding matrices, we kind of ask, can the internals of the language model be effectively repurposed for this? So I'm going to go over our first set of experiments from 2020, which were done on kind of medium-sized LSTMs, but I'd love to talk about kind of like the transformer reproductions and the follow-ups that I've been doing. But so firstly, we lay down two random baselines, right? And these are just from randomly sampled tokens. So the pre-training that you do is that you take a big corpus of just sampled, of just like random tokens. They can either be sampled from a uniform distribution or from a Zipfian kind of language-like distribution. And so this provides a control, of how far can we get with just word embeddings. Anything kind of less than this means that the network internals are somehow useful, right? And that the kind of bias that they have is interesting. And another thing that we see from this is that vocabulary distribution does have a very significant effect. Of course, the Zipfian is better, but of course it's very it's hard to really see because they're both very high. So in our first set of experiments, we pretrained on music, and this is MIDI data. It's the Maestro data set, so it's like classical piano, MIDI data. MIDI has this like small vocabulary of a few hundred tokens, and it kind of perfectly describes a piece of music if you exclude timbre, with things like when notes are pressed, when they're stopped, how hard they're pressed, all that. And on the other hand, we use code, which is just Java with the comments removed, so we don't have any kind of leakage of real language. We use what's called the habeas corpus for this. I don't know what that means, but yeah, I think that's yeah. We use the habeas corpus for Java, and what we find is that there's this impressive improvement in perplexity. Especially considering that we're just using the all we're allowing to be tuned are the two matrices, and especially since the MIDI surface form is very different. But, because music and language have these structural similarities, and code does as well, perhaps more, perhaps the better inductive bias, as we see from this, like, pretty large difference, we can get this, like, huge improvement over random. And so now the natural question to ask, especially for those who have been maybe a bit more like inoculated with linguistics, is this because of hierarchical structures? Is it because human language is like deeply recursive, and like the abstract that underlies it is recursion, as some people believe, and code also has all the brackets. It's kind of very neatly recursive language. And music, well, some people, there have been kind of generative theories of music that do kind of posit kind of some similar claims to what's been made about language, and it is and we can see how like on many scales things repeating, you can maybe say that it's hierarchical. And so this is a very interesting question, and what's cool is that it's testable, right? We can if what we think is that like what's being shared is if we take away the sauce from language, music, and code, there's this underlying recursive structure, and that's what's causing this. We could say, like, okay, what if we just totally take away the sauce from the pre-training and just train on nesting parentheses? But we should also have the control, right? Because we want to really control kind of in this domain where we have this vocabulary of parentheses and they're matching. What if we do that same thing where we have this large vocabulary of parentheses and they're matching, except that they don't really, there's no recursion. They're just kind of placed a distance apart. We actually sampled the distances, so they're kind of like language-like dependency lengths, but there's no structure to it. And what we see actually is that this is that this works very well, right? And so that putting just a simple underlying structure causes this huge increase in performance. But I think what's really interesting about this set of experiments is that flat parentheses are as good as hierarchical parentheses. And what's very interesting is that the flat parentheses corpus, it's very similar to the random corpus, right? So it's like you sample a in terms of like in terms of like the deep structure in it or something, it's like you sample a vocabulary item, and on the one hand you place it once for the random, for the other hand you like place it twice, but and then on to the next vocabulary item, forgot the previous one, no thought about that. There's no structure in any way that links tokens to each other apart from the two that are matching. And yet we see this huge drop, right? The difference from placing a token twice instead of once is huge, right? It's like 300 perplexity point, which in these language models, which again are LSTMs, so their best case perplexity isn't huge, like it's over 50. This is huge. And so what to take away from these experiments is that, a structural inductive bias, but not necessarily a hierarchical bias, is very important to help learning language. And that, I think what these experiments do is that they point out that these flat head-to-head dependency structures, right? So where there's not necessarily a deep nesting structure, but there is there is kind of this idea that there's kind of this predisposition to relate one thing to another. Whatever scale this is in, is like a very important bias for kind of being equipped to learn language. As much, in this case, it came out to be as good as like a Dyke language, which is like very foundational in some people's view of language. These results have been reproduced in transformers. I don't have much time, but yeah, there's two papers kind of reproducing these results in transformers with some interesting subtleties to how this pans out. Yeah, and I'd also love talk, about the follow-ups that we're doing to this if people have questions. And then just one other exciting result that I've seen is Krishna et al. Does pre-training for summarization require knowledge transfer. And what they do is that they just take a totally like what they call a nonsense document, like a random corpus of just random non-words, and they create these summarization input-output pairs, right? So meaning that you take the nonsense document and you like take the third sentence or something, and then like that is a summary, and they have many different ways of these tasks. It's not always the third sentence, but what this effectively does is that it creates input output, and then they model this with a T5 type model, so a text to text, and what this does is that it creates creates dependencies, they're like simple kind of summarization type dependencies, but they're totally kind of flat and meaningless, right? They're not like kind of linguistic, discoursey, structural dependencies. But this gives them good downstream performance, worse than, but very comparable to the actual T5, being fine-tuned on summarization, which I think is crazy. I think this is a great paper. I'm very interested in it. So there's another section which looks at languages, real languages for this, but and syntax. But I think we do not have time. So I'm gonna conclude by going back to this issue. What have we learned poking around in LLMs? None of it is really like material evidence, about linguistics. But, firstly, by looking at the embedding space of multilingual LLMs, we can kind of pick apart the complexities and dualities, of universal properties like subjecthood, and get kind of nice understandings into how they might function. And then, secondly, pre-training with structural primitives, as we did in that second part, demonstrates what starting points make language learning possible in this empirical way that is kind of new, right? We couldn't have done this before language models, and I think it gives us very interesting ideas to work with as we continue thinking about language. And just to go over more in more detail of the two parts of the talk, right? In subjecthood, we've seen that one embedding space can encode property that's generalized across languages, a property that's like both discretely defined and influenced by prototype effects, and the higher order features of the language, right? Starting to get this like syntax lexicon continuum. And by looking at structural primitives and non-linguistic pre-training, we're in a unique position where we can make powerful learners that are imbued with known inductive biases. And the big kind of takeaway from these questions is that these flat kind of dependency relations are an important and interesting bias. Thank you. I hope you enjoyed the talk. I'd love to talk offline or at SIGTYP about all this.